Okay, today we're looking at 8.3, which is using intercepts. We're going to graph using something called intercepts. Okay, this is a little easier, I think, than using tables. A lot of times it's easier. We'll learn one more way before we finish this chapter out, but this is a good way to get 2 points and then draw a line through them. So instead of having a table of 5 points, we're going to just have 2 points with each of these, and we're going to draw a line through each point. Now, what I want to talk about is the word intercept. Now, when we're talking about intercepts with lines, we're talking about the place where these lines cross the axis. So if we look here, where this line crosses the y-axis is called the y-intercept. Okay, the y-intercept is the y value, which is -4. But the coordinate for the y-intercept is 0, -4. Okay, now where it crosses the x-axis is right here. That's called the X-intercept. Okay, intercepts deal with crossing axes. Okay, so the X-intercept is -3, but the coordinate for the X-intercept is -3 and 0. Okay, let's look at the yellow line. Where it crosses the x-axis is the X-intercept, and that is -8. The coordinates for that would be -8, 0. Where it crosses the y-intercept is right here, or the y-axis, I'm sorry. That's the y-intercept. The coordinate, y-coordinate for that is 6. Y-intercept is 6, but the ordered pair that describes that location, 0, 6. So I want you to notice, let's look at these two intercepts, the two y-intercepts of these lines, and notice something that's similar. We have an x value of 0 here and an x value of 0 here. So the first thing we need to know is for every y-intercept, every ordered pair that describes a y-intercept, the x value is always 0. Everywhere a line crosses the y-axis, the x value is always 0. Okay, so we need to know that. Let's look at the x-intercepts. We'll notice what's similar about these two. Here, the y values are 0. That's the second thing we need to know. Okay, for every x-intercept, every ordered pair that describes an x-intercept, the y value is always 0, because everywhere a line crosses the x-axis, the y value is always 0. So that is the second thing we need to know to use intercepts to graph lines. And we're going to do about 4 examples of this, and that's going to be all we need to do today, I think, and one word problem. So what we're going to do, we're going to find the intercepts. And remember, we just showed you that the x-intercept has a y value of 0, and the y-intercept has an x value of 0. So we're going to find the x-intercept and the y-intercept. Well, how do we do that? Well, to find the x-intercept, I say that y is 0, because I know that y is 0 wherever it crosses the x-axis. So I'm going to plug 0 in for y. So I would have 2 times 0, right? Well, 2 times 0 is 0. Okay, so this in effect goes away. So I've got 3x equals 6. What does x have to be to make this true? Well, it has to be 2. So we see that the x-intercept is 2, 0. Okay? Let's go back a little bit. 2, 0. Now let's look at this. The y-intercept is where x is 0. So if I plug in 0 for x here, 3 times 0 is 0. That goes away. So -2y equals 6. What does y have to be? Well, I think y has to be -3, doesn't it? To make +6. So the y-intercept is 0, -3. Now I'll just plot the points. So 2, 0, got a point here. Then 0, -3, I've got a point here. Then I'm not going to do a straight one. I'm just going to kind of try to get it in there with this tablet. It's kind of hard for me to do. You will use a straight edge, and you will have a line going through those 2 points, and you're done. Okay, let's get out of that, and let's do the next one. Okay, again, I'm going to find 2 points, both intercepts. Okay, I'm going to find the x-intercept. Well, where the x-intercept, y is 0. I'm going to find the y-intercept. That means x is 0 in this one. Okay, so if y is 0, I'm going to plug 0 in for y, and I'm going to solve for x. Well, if y is 0, this goes away, right? X equals -2. Okay, -2. Now I'm going to plug 0 in for x and figure out what y has to be. Well, if x is 0, that goes away. -2y equals -2. Y has to be 1. There are my points. Okay, -2, 0, and then 0, 1 right there. And then you will draw a line through those points. And we have graphed that. Next one. Get rid of that point. Okay, again, 2 points. Our first point is the x-intercept, so y is 0. Our second point is the y-intercept, so x is 0. I'm going to plug y equals 0 here. 3 times 0 is 0. 4x equals 12, so x has to be 3. If y is 0, x has to be 3 for this statement to be true. Okay, now if x is 0, I've got 3y equals 12, y is 4. Okay, so 3, 0, and 0, 4. And I've got a line, and a very bad one at that, that goes through those 2 points. Okay, let's look at this last one. Again, notice I'm just doing the same exact thing every time. 2 points, comma, comma. X is 0, y is 0 for the x-intercept, x is 0 for the y-intercept. So with each of the points, I put a 0 in for y, and then I put a 0 in for x for the other one. Now, y is 0, so I'm going to plug 0 in for y here. So this may require a little bit of thinking. If y is 0, what does x have to be to make the statement true? Okay, well, if you can't tell by looking at that, just solve the equation. You get negative 2x equals 8. Divide by negative 2. X equals negative 4. So in this case, x would have to equal negative 4. Now, most people can look at that and tell, but if you can't, just solve the equation and work it out and find out what x equals. Next, we're going to put 0 in for x. Well, this is a little easier. If I put 0 in for x, this whole thing equals 0, so y has to be negative 8. So I've got negative 4, 0, 1, 2, 3, 4. Then I've got 0, negative 8. 10, I think this is negative 8. Okay, now we want to just draw a line through those 2 points, and I totally missed that. That's pretty bad. I would count off if you did that, but I'm not going to count off of myself here. Okay, that's graphing using intercepts. Let's do one more. We'll do a word problem. Know with any word problem you do today, you're going to have 2 variables, an x and a y. You'll probably have a total. So let's read this. You're canoeing along a 12-mile stretch of river. You travel 4 miles per hour when paddling and 2 miles per hour when drifting. Write and graph an equation describing your possible paddling and drifting times. We're looking for times, okay? Give 3 possible combinations of paddling and drifting times. Okay, so we're looking for time. So if I paddle and I'm going 4 miles per hour and I'm looking for how much time I actually paddle, I don't know that. We're going to call that a variable. We'll call that x. Also, if I'm drifting, I go 2 miles per hour, but I don't know how much my drifting time would be, so I'm going to just call that y. Notice this is going to be different because this is paddling time, this is drifting time. Well, if I add those 2 things together, that's going to give me my 12-mile distance that I've got to travel. Okay? And again, to graph this, we're simply going to get 2 points. For the x-intercept, 0 is y. For the y-intercept, 0 is x. So if I plug 0 in for y, 2 times y is 0, so 4x equals 12. X has to be 3. If I plug 0 in for x, that goes away. 2 times y is 12, so y has to be 6. Okay, so this, don't think of this as a box. This is just something I can graph on. But this would be, if I had a straight edge, this would be my axis. Okay? With a real world problem, we're not going to have negatives. So we're not going to have a quadrant. We're not going to have anything over here or down here or over here. So I don't need to keep going with these lines because it's real world. It's just positive. Okay. So we're going to graph 0, 6. I'm going to skip a line for every one. So each line would be a half. That'd be 1, 2, 3, 4, 5. I think I did that right. So I have a point here. And then I have 3 zeros. So 1, 2, 3. Point here. Now, since we have no negatives, we start and end. That's going to be straight, obviously, but we're going to start here and end here. Not going to keep going with this. It's not a line because it's real world. Okay, it's a real world problem. Meaning, I'm not going to, let's see, if x is 0, I'm not going to actually drift more than 6 hours. If I do, I've gone over my 12-mile stretch. Okay, so I don't need to do that. Okay, now it says give 3 possible combinations of paddling and drifting times. So all I need to do is give 3 combinations that work, that make this statement true. Well, let's say x is 1. Okay, let's say x is 1. What does y have to be to make this true? Well, if x is 1, that's 4. Y has to be 4, right? 8 plus 4 is 12. Let's say x is 2. Okay, if x is 2, that's 8 2 times y would have to equal 4, so y has to be 2. Okay, so you see what I'm doing? I'm just finding things that work in this equation. That's 3 possible combinations. All of these points are going to lie on this line if we graph it. Now, it's not going to lie on my line because it's not straight. But all of these points here should lie on your line, or we've done something wrong, because these are all solutions. Okay, let's say, and we also can use these 2 points that we found, because these work also. 3, 0 would work, wouldn't it? Okay, that works just fine. If we do a y, let's do another one. Let's say y is 1, or let's say y is 2. If y is 2, then x has to be, what is that? 2, right? So 8 plus 4 is 12. Okay, so there's 4 combinations actually, and if we use this one, we have a 5th one. Okay, so today, with every equation, we're not solving for y, we're just getting 2 points. Okay, one in which y is 0, one in which x is 0. We're going to plug these numbers into the equation. We're going to find a value for x and a value for y in these different points, and then we just plot the 2 points and draw a line. And we are done for today.